BIPV has a lot of challenges. You know, there's a lot of issues. There's lots of things that people have to go through to actually get BIPV approved, and not only that, but the whole project issues are tremendous, because you're not dealing with one product, you're dealing with a building. But there's been challenges. One of those is safety. Why is that? What's been the problem there?
Let's say it's not a problem, not for us, because we are coming from the glass business, and in glass business you have special regulations for especially laminated safety glass. On one hand, it's regarding fall preventing. That means if you have a balcony, then you need special glass that you be on a safety side. On the other hand, you have overhead glassing. That means if the glass is broken, it's not allowed that splinter come down from the glass. So there are special regulations, especially also in Germany, and we made a special certification for our laminated safety glass. We know it from the glass business. There is a special laminated safety. The big question was always, is it also possible to build PV panels with solar cells inside, and to get the approval that it's laminated safety glass. And we made it last year with the German Institute for Building Technology, and since December we have the approval, and so we can install these panels like a standard laminated.
So that takes a lot of the risk out now, you know, and all the doubt about whether the laminates are to the standard of normal laminated safety glass.
Yes, that's right. Yes, and this is a big issue for architects, because if they don't have a product which is certified, then it's risky in the project. They make a plan for a building with solar panels, and maybe the authority says no, it's not allowed, then you should change everything, and so.
And I see here on your booth you've got some very, very different looks for panels, even with holes in the actual cells. This is very, very different, and it seems to me as if people are missing out in the design areas. Has this also been a challenge, that architects feel that this is quite a boring thing to try and integrate?
Yes, you know, the big picture from photovoltaic is solar farms and rectangular panels on rooftop, and this is usually not interesting for an architect. And our job is to change the mind, to bring possibilities to architects, to say, okay, it doesn't make sense to give an architect a panel with 1 to 2 meters and say, build your building around the panel. This is impossible. So we go the other way around. We say, you have your building and we design it for your building, regarding the shapes, regarding the measurement, regarding colors, cell types, and so on.
To an architect, design is everything, and a challenge has really been that designing in solar is very boring. It's very, very restrictive. So with the ability that I've seen here, that you can do it in different ways, is that another way of breaking down the barriers for solar to be used in buildings?
Exactly, because usually architects don't like a existing material or a shaped material. They want like to design and to make their own variations and so on. And we give architects the possibilities, and sometimes it's a difficult process to get on the project, to find a solution for architects, but sometimes we develop also new solutions like cells with different holes inside. Usually they are rectangular, but we can make also with other companies, with the cell producers, rounded holes and so on. And so it's a big challenge, but it's also interesting with the architects.
Now, many countries that have a feed-in tariff also provide an extra incentive for actually employing solar in a BIPV application. But tell me some of the challenges you have with that, especially in the UK. There's a problem there, isn't there?
Yes, on one hand, let's say BIPV is not always related to feed-in tariff, because if you go to architects or to customers, to house owners who are willing to install something nice things, then they say yes, it costs money, but maybe there is a payback from the electric power, but the big issue is the design, not the electric output in many cases. But in UK is a special thing with the MCS. There is the MCS 5 is for standard PV panels, but there are more and more projects in UK where you have to integrate PV because of different certification standards like the BREEAM, where you should come down with your CO2 output for your building, and PV is a very good solution for that. And for this reason, you need the MCS 17. And this is at the moment a little bit difficult because there is no authority who is allowed to certify us. So we should go the way together. Now we are on the way, but it's a long way. But I think we should finalize it in 1 or 2 months. Then we have also the MCS 17 for UK. It's called BIPV, so it means bespoken building integrated photovoltaic.